So I had a question on this one. Your question specifically, I think, is going to be this part. I'm going to run through the whole thing just so I can post the video as a supplemental for the problem. So when you dive below the surface of the water, the pressure increases. You can feel this in your ears as you dive from the bottom to the bottom of a swimming pool. The function that describes this relationship is pressure as a function of distance equals this stuff, where d is depth. So we're putting in how deep we are underwater, and we're getting out p, pressure. So pressure is a function of depth. And then all of these will ask you to select the correct units. And so if we're looking at depth, it's going to be feet. If we're looking at what we're finding pressure, the answer is pressure. It's going to be PSI or pounds per square inch. And what that is to keep you kind of cognizant of which piece it is that you're solving for. We're solving for the output or the input. So for this first question, we have what is the pressure at the surface of the water, and then select the correct units. So what I translated what is the pressure at the surface of the water to is find P, so what is pressure? We'll find P when D, that's our other one, is 0, because if we're not underwater at all, D is 0. And so if we plug that 0 into the function they gave us, it knocks out this ugly fraction, and we're left with P of 0 would equal 14.5, or P equals 14.5. And that is pressure, right? So that would be pounds per square inch. This next one, at what depth? Okay, find D. When the pressure is exactly double the pressure at the surface. Okay, so the pressure at the surface was 14.5, so double that would be 29. So find D when P is 29. So now we're putting 29 in on the P side of the equation, not the D. Careful not to plug it in the wrong side. And then we're going to subtract over that 14.5, which leaves me at 14.5. Sorry, my recorder cut out there. So I think I had just subtracted over this 14.5, and that left us this little mess. And then you could just throw this in a calculator, and you'll come up with 33. I reduced, but it's all good. Just throw in a calculator. And so then we get that the depth would be 33 feet when the pressure is double at surface level. Part C, what is the pressure at a depth of 297 feet? So find P when D is 297. And then read the directions, unlike me, who had to come back and do some whiteout here. Use function notation in the first box to give the answer, and in the second box, select the correct units. So here, this is just saying find P when D is 297. So the function notation they're talking about is saying what we're doing is we're finding P of 297. So that's what they're looking for in this first box right here. And then you just toss that in there and do the math, and then that comes out 145. And this is, yes, and so then the next one is the exact same thing. It's just saying 330 feet for D. So toss that into that. And then the last part asks us to identify which of these graphs would be represented. And so we know when P is 0, or sorry, when D is 0, the pressure is 14.5, and we know it's going to increase. So this has the right intercept, but it's constant. So this is just like if you were floating around at surface level, not the right intercept, not the right intercept. So it's got to be this one. There's 14.5 and increasing. So that would be the graph. Hopefully that helps.